Hello and welcome to Food Safety Fridays, edition 129. Today's topic is wet cleaning and CIP, and the guest presenter today will be Megan Coy from AIB International. It's lovely to have you along. Yep, say hello in the sidebar. Tell us where you're joining us from today, normally from all over the world. Wherever you're from, you're very welcome. We're looking forward to a great session. This is the last one of 2019, boo-hoo. But next year, we already have planned 30 Food Safety Fridays. So we'll be putting up the schedule over the holiday period. And in the new year, we'll be kicking off with our first webinars in January and 30 throughout the year. Okay. 2019 Food Safety Fridays has been sponsored, as is hopefully next year as well. And I'll play the sponsor ads now, and then we'll introduce you to Megan.
The world of food has changed a lot in the last 100 years. But one thing that doesn't change? Ensuring the quality and safe handling of food. No matter what changes are yet to come, we're proud to always be on our clients' side, shaping the future of food, today and tomorrow. AIB International, ever onward.
Okay, thanks to the kind sponsor of Food Safety Fridays. Just to say, it is being recorded today as always. The recording, slides and certificate of attendance will be circulated by email, normally 1 or 2 hours after the webinar. Okay, I'd like to introduce you now to Megan Coy from AIB International. Good morning, Megan.
Good morning.
How are you doing?
I'm good. How about yourself?
I'm fantastic. It's Friday, so
Yes.
best day of the
Yes.
week.
Great.
Do you want to just tell everyone where you're joining us from today, Megan?
I currently live in Baltimore, Maryland, so on the East Coast, kind of in the heart of the city of Baltimore.
Okay, and the weather? We always
the weather is pretty crappy today. It's raining off and on, and slight chance of some scattered snow, I heard maybe. So, yeah, it's not pretty.
Well, let's try and spread a bit of sunshine with the presentation. So, okay, I'll get your slides up, Megan. I'll be back for the Q&A later, but for now, if we switch webcams off, there we go. I'll be back later.
Okay, thank you, Simon. So as you heard, my name is Megan, and I'm one of the QA regional managers with AIB International. So today we're going to be covering the topic of wet cleaning and CIP. So before I begin, I'd like to offer a brief introduction to AIB International for those that may be unfamiliar. For about 100 years, this year is our centennial, AIB International has been committed to partnering with our clients to ensure the enjoyment of safe, high-quality food everywhere. Through our customized training, inspections, and consulting, regulatory and certification services, our global team of food safety and quality professionals in 120 countries helps our customers address virtually every link in their supply chains. That's because we believe everyone deserves safe, high-quality food and continue to share our insights and expertise with the industry to make that a reality. So our agenda today is to discuss cleaning versus sanitizing, wet cleaning steps, and clean in place and clean out of place. So first we have a question, why do we clean? Do we clean because it's required by regulation or customer? Do we clean to produce food safe and high quality products? Do we clean to ensure a clean work environment? Or do we clean to avoid pest harborage?
Okay, I have loaded the poll in the sidebar if you will just make your choice. Why do we clean? Required by regulation or customer, produce a food safe and high quality product, ensure a clean work environment, or avoid pest harborage. And hopefully you can see that, Megan. The moment it's about 85% produce a food safe and high quality product, then about 10% ensure a clean work environment, and then 0 for required by regulation or customer and avoid pest harborage. So how are they doing?
Okay, well, it's kind of a trick question. So the correct answer is all of the above. So we need to clean based on the facility equipment, based on the regulatory requirements, such as potentially what applies to the product being produced, the PMO or the Pasteurized Milk Ordinance, the CFR, Code of Federal Regulations, or regulated HACCP. A customer may also define your cleaning cycles based on the quality of their product. Cleaning maintains a food safe and quality product. If cleaning did not occur, you can have microbial growth, creating undesirable outcomes. A clean environment at work is also essential for employee morale as well as safety. And product debris can become a pest harborage issue if not addressed. For instance, bakeries need to clean their overheads for flour dusting to prevent any flour beetle harborage in the overheads over product. So as stated, the CFR does have some regulations around when to clean food contact surfaces as well as non-food contact surfaces. So the CFR states that food contact surfaces, including utensils, in wet cleaning need to be cleaned and sanitized before use and after any interruption during which the food contact surface may be contaminated. Then it states the non-food contact surfaces must also be cleaned as frequently as necessary. So wet cleaning is required to protect against allergen cross-contact as well as microorganisms into food. The PMO might also state a more specific cleaning frequency, such as every 72 hours for pasteurized milk silos. So the next question is, why do we clean? Or what do we clean? Food contact surfaces, non-food contact surfaces, and the building. So everything inside the building is essential to be cleaned. Some areas are more critical than others, but everything would need to be cleaned at some point. Also, how we clean is important. Cleaning of one area should not contaminate the cleanliness of another. So by cleaning those overheads or the building walls or ceilings, the equipment in the surrounding area might need to be covered. Several issues have been reported that when cleaning the walls of a production room, the high pressure water was spraying listeria from the walls onto the equipment, causing recalls. So this is necessary to know why or what we should clean and also how we should clean. So cleaning versus sanitizing, is there a difference? Yes, of course there is a difference, and we will discuss that in the next upcoming slides. So first, cleaning is defined as the process of removing unwanted substances from surfaces. Cleaning is done before sanitizing to remove visible debris. It also removes some of the non-visible debris, such as microorganisms, so it helps minimize physical soil contamination as well as microbial contamination. Sanitation is the application of any effective method or substance to clean a surface for the destruction of pathogens as well as other microorganisms as far as practical. Sanitizing is completed after cleaning and takes the surface to an acceptable clean from a microorganism standpoint. It also should not adversely affect the equipment, product, or health of the consumer. So in summary, cleaning versus sanitizing differences are: the cleaning removes the visible soil, sanitizing removes the invisible to the naked eye like microorganisms, but both affect the cleanliness and microbial growth of the facility and the equipment. While these terms are used interchangeably, sometimes they are two different steps and both are needed for an effective cleaning program. So now we will move on to the common steps of a wet cleaning process. So our steps range from numbers 1 through 8, and some of them might be included in all wet cleaning processes, and some of them might not be included in some of the wet cleaning processes. It depends on the equipment and the chemicals used. So our first steps are the pre-clean and pre-rinse. So the pre-clean would remove the excess product, food, and debris, which could be dry cleaning, including sweeping or wiping down any of the surfaces to remove any of the excess product being produced. Then the pre-rinse would remove any of the remaining particles to remove anything visible to the eye before the washing step occurs. So in our pre-rinse, our water is a very important factor in this. The CFR also states what the water supply should be. The water must not be a source of contamination to the product or the food contact surfaces. So it must be derived from an adequate source, and any water that contacts food, the food contact surfaces, or even the food contact packaging materials must be safe and of adequate sanitary quality. So here's our other question. Do you know your water source, and do you know your water chemistry?
Okay, that's not, I've not added that as a poll. So just type in yes, yes, or no, no, or yes, no, or no, yes in the sidebar to those two questions. Do you know your water source? And do you know your water chemistry? So just quickly type that in the sidebar if you can. So let's see if we can see lots of yeses. Hopefully, yes, we can. That's heartening, I think. Most people do know their water source and do know their water chemistry.
Great.
Okay.
So the pH and the hardness are the common factors of the water. So the simple definition of water hardness is the amount of dissolved calcium and magnesium in the water. Hard water is high in dissolved minerals, largely the calcium and the magnesium. The harder your water is, the cleaning products may become less effective, as hard water causes difficulty in creating a soapy lather. Hard water also creates crusty deposits known as scale on your equipment surfaces. So softer water lathers well when detergent is added. The impurities of water can drastically alter the effectiveness of the detergent or sanitizer. Water hardness is the most important chemical property with direct effect on cleaning and sanitizing efficiency. Water pH, though, also generally ranges from 5 to 8.5, and this range is of no serious consequence to most detergents and sanitizers. However, high alkaline or high acidity water may require additional buffering agents. Water can also contain significant number of microorganisms. Water used for cleaning and sanitizing must be potable and pathogen-free. Treatments and sanitation of water may be required prior to using any cleaning regimens. This would mean you would want the water to fall in a neutral point, allowing the full effectiveness. So in summary, your water used for wet cleaning should be free of objectionable tastes or odors, be free of disease-producing microorganisms, free of metal ions, which is the hard water, and free of any alkali or acidity. So our next step is washing. which is the main cleaning step in your wet cleaning cycle. This loosens surface waste and other materials, including the visible and invisible, and usually uses a detergent. So the main components of the washing step would be time, action, chemical, and temperature. Time is the contact time of the solution. So the time that the solution, the detergent mixed with the water, is in contact with the surface. The action can be manual or automatic. Automatic would be something like a CIP, which we will discuss further in the presentation, or manual would be the personnel using a scrub brush and some solution in order to clean the surfaces. Other actions can be to penetrate, dislodge, disperse, or redisposition. The chemical is the amount of chemical used, or the concentration or conductivity. The label of the chemical will disclose the amount of chemical to use. The range is usually depicted in parts per million or ounces per gallon, and this can be determined by a titration. The temperature is the temperature or the degree of heat of the water. So the water temperature could be hot as a hot wash or an ambient temperature. So then in your concentration or your chemical solution, sometimes the concentration from the label can be out of range. So for a high concentration, you want to ensure there is a rinse afterwards in order to remove any extra chemical that was used. For a low concentration, you want to make sure a reclean occurs in order to increase the concentration and make sure that the surface is actually cleaned. Some common classes of chemical components are basic alkalis, which is a chemical compound that neutralizes with acids and turns the litmus paper blue, typically a caustic or corrosive substance of this kind, such as a lime or a soda. Complex phosphites is a salt or ester of phosphoric acid. Surfactants are a substance that tends to reduce the surface tension of a liquid in which it is dissolved. Chelating agents are chemical compounds that react with metal ions to form a stable water-soluble complex. Acids is a chemical substance that neutralizes alkalis, dissolves some metals, and turns the litmus paper red, typically a corrosive or sour-tasting liquid of this kind. Oxidizing agents in chemistry, an oxidizing agent or an oxidizer is a substance that has the ability to oxidize other substances. In other words, to cause them to lose their electrons. In the second case, an oxidizing agent is a chemical species that transfers electronegative atoms, usually oxygens, to the substrate. And then the solvents is a liquid, typically one other than water, used for dissolving other substances. So these are just some of the chemicals that can be used during the washing step. Our next steps would be a rinse. So after the caustic wash or the washing step, the next step could be a rinse and is completed, and then it completes an inspection of the areas to ensure that the surfaces are clean. So the rinse may not be required depending on the chemical solution or the chemical used. This would also be depicted on the label. And then the inspect visual or swab, so a visual inspection after the washing step would be done in order to look at the surfaces to make sure that they are clean and have no product debris left behind. And then a swab could be an ATP or a micro swab, which we'll define further on in the presentation, in order to ensure that the surface is now clean. Our remaining steps are disinfection, which is the sanitizing step defined earlier. Final rinse, which removes the disinfectant if required. If you use an alcohol-based sanitizer, you might not need a final rinse afterwards. And then drying removes the moisture and allows the production to start up clean. Types of disinfection include the sterilizer, which removes all microorganisms and other pathogens from an object or surface by treating it with chemicals, or high heat and radiation. A disinfectant kills a wider range of microorganisms than sanitizers. The disinfectants kill certain bacteria, viruses, mildew, fungi in a specific period of time and also regulated by the EPA. The sanitizer is defined as cleaning something to make it free of bacteria or disease-causing elements, and in order to be a sanitizer, 99.9% is required. So our verification step would be part of the swabbing or the visual inspection, ATP swabs, rinse water tests, or sensory. The ATP swabs are a verification method to prove the cleaning was effective. So ATP is adenosine triphosphate, which is present in all organic matter, and the swab detects the presence of ATP left behind to determine the cleanliness. A rinse water test proves that there is no chemical residue left in the system, and the sensory can also be completed to ensure that there is no residue left behind. Also, cleaning should be validated. So how do you know that your cleaning procedure is effective? So allergen residue swabs, micro swabs, and product testing are ways to validate your cleaning procedures. This will ensure your cleaning procedure is able to remove the allergen protein, if applicable to the products, and the microbes from the surfaces during cleaning. Testing the first product ran after cleaning can also be a way of showing the cleaning is effective. So the verification step is, did the cleaning work? And the validation is the cleaning effective? So the validation might not be done every time after cleaning, but should be done in order to prove that your cleaning procedure is effective. So now we will move on to the cleaning methods. So different cleaning methods include CIP, which is clean in place, COP, clean out of place, foam, gel, fogging, or soaking. These are just some of the common wet cleaning methods, and now we will dig a little deeper into the CIP and the COP. So CIP, as I stated, is clean in place. Procedure of cleaning interior product contact surfaces such as process pipes, vessels, and equipment without disassembly. So the clean in place means that things are left in place for the cleaning steps. So some possible CIP or clean in place systems are a 1 tank, which is the combined rinse and wash, a 2 tank, separate rinse and wash tanks, 3 tanks is a rinse, wash, and recovery, 4 tank, any combination of rinse, wash, alkaline acid, sanitizer, and recovery, inline or in-tank chemical dosing for 1-pass chemical usage systems, and separate chemical tanks for alkaline acid and sanitizer for multi-pass chemical usage. So these are just some of the common CIP systems, and any one would be effective if all of the cleaning process steps are followed. So here is a picture of the different systems as well. So the first picture would be the 1 tank, followed by the 2, 3, and 4. So these are just some of the systems that you could see in a production facility for CIP systems. And then this picture follows the flow. So just a flow of a common CIP system, the water or water detergent solution will flow to the equipment and back to the CIP skids as regulated by the flow meter. So the detergent tank would be there that has the detergent solution, and the pre-rinse tank there as well. So the steps for clean in place follow the same steps as previously discussed with the wet cleaning. The pre-rinse would be used to wet the interior of the surface of the lines and tanks, remove most of the remaining residue, dissolve sugar and partially melts fats, and provides a non-chemical pressure test for the CIP flow path. Then the caustic wash would happen, which softens fats, making them easier to remove, and used as the main detergent in most CIP washes. So the caustic wash would remove the remaining visible soil left behind from the rinse step. The next steps would be the rinse after the caustic wash if needed. So fresh water flushes out the residual traces of detergent remaining from the caustic wash. Then a sanitizer step, which is the disinfection, and then a rinse if applicable based on the sanitizer used. These are the same steps as previously discussed in the wet cleaning section. So also the critical monitoring for the CIP is the same as the wet cleaning process. So TACT still comes into play: time, temperature, concentration, time, action, chemical, and temperature. So the time is the detergent and the sanitizer must be in contact with the equipment for a sufficient amount of time. This would be based on the CIP system and how it's regulated. The flow rate is the action. So this would be part of the automatic action that we discussed earlier. The flow rate provides the turbulent action needed to remove the soil. The flow rate is generally calculated in gallons per minute and based on the number of valves open during the CIP process. Continued critical monitoring would be the chemical concentration. So again, the amount of chemical combined with the water is needed to ensure removal of the soil and reduction of microorganisms on the product contact surface. So again, the concentration should be in the defined range based on the label, and you should not have less or too much, too little or too less of the chemical in the concentration. Then the temperature is the appropriate temperature of the water when combined with the chemicals to ensure an effective cleaning. So there are also caustic CIPs and acid CIPs. So the caustic is the alkaline detergent, while the acid CIP is an acid wash based on the different classes of chemicals used. Caustic CIP is meant to be used more frequently as it gets rid of fats, oils, and greases. Acid CIP is used less frequently and is used after the caustic CIP to get rid of any mineral soils. The advantages of a CIP system is it minimizes mistakes, keeps employees safe, allows more production time, allows for product quality, and has utility savings if the recovery system is used. Automating cleaning reduces the chance of human error that can contribute to an unsafe product. This reduces chemical exposure by containing the cleaning solutions within the system. As less production time is lost to cleaning, more time can be spent making product. Reliable and repeatable cleaning means sustainable product quality, consistency. Less contamination means fewer product recalls and higher brand confidence, and water and energy usage is reduced through the repeatable control system. Another type of wet cleaning is COP, which is clean out of place. This can also be manual or automatic. So the disassembly of some equipment is necessary to complete a good cleaning. These parts include any fittings, clamps, impellers, hoses, conveyor belts, or anything else that is not included in the CIP system. These can be cleaned manually by personnel with a brush or bucket, or in a tank through an automated system, similar to a CIP system, but in a COP tank. This also includes a rinse, caustic wash, rinse, and a sanitizer step within the COP tank. The COP tank would use a turbulent flow to clean the parts in the system, and you can control it through the time, action, concentration, and temperature as well, just like the CIP system. Other cleaning methods previously discussed is a foam, a gel, fogging, or soaking. So a foam is a chemical and water solution sprayed on the equipment or surface and left there for a defined period of time before it is rinsed off. The time allows the chemical to react with the surface and anything left on the surface to remove it with the rinse. Best practice is to rinse the foam from the top to the bottom. A gel solution is similar to the foam, but is just a different kind of solution than a foam solution is the gel solution. It's also left on for a defined period of time before being rinsed off. Fogging is similar to a foam in the fact that it's sprayed out of a nozzle and left on for a defined period of time. This uses compressed air to generate a mist of the chemical solution. The solution settles on the equipment for the bacterial effect and can also be used for pest control when using a proper pesticide. Then the soaking is simple as stated. It's soaking the parts in a solution. This can be used for a sanitizer after parts are cleaned. So once the parts are cleaned, it can soak in a sanitizer solution until it's ready to be reassembled. So in summary, cleaning versus sanitizing are two different steps, though commonly interchangeable. Cleaning and sanitizing are both needed for an effective program. What to clean is essentially everything within the building at defined frequencies. Why we clean is because we want to have a safe product. And the cleaning methods used is wet cleaning is one of the cleaning methods, and then there's also different cleaning methods within the wet cleaning, such as we previously discussed, the CIP or clean in place and COP clean out of place. However, there are other methods that can be used based on the product, such as a dry cleaning method based on the products being produced. So if you'd like more information about this webinar, you can go to aibinternational.com/webinar help. And then I believe we will open it up for questions.
Yeah, sure will. Thanks, Megan. If you can switch your webcam on, and then we'll get rid of the slides. Thanks for that. A lot of great information there. And already I can see there are lots of questions. So, where have you gone? There you are.
Yeah, sorry.
No problem. So first one from Mona. Difference between sanitizer and disinfectant?
So the sanitizer and the disinfect are very similar. If so, the only difference would be based on the chemical used. So the sanitizer has to be a certain regulation based on the EPA. So it also used to disinfect a surface.
Okay, next one, Kevin Dantzler. How can testing product right after cleaning be used to determine the effectiveness of your cleaning process?
So it would be if you're testing product for any pathogens that might have been left behind at the surface, the first product that's run through, the batter, the dough, the beverage, whatever you're producing, the first product to run through, you test that for pathogens to make sure that there is nothing left behind and then got into the product.
Okay, next one, Preet. Are there any specific regulatory requirements on the cleaning frequency in the hot fill beverage stroke juice manufacturing? If not, what is the typical CIP frequency in the beverage industry?
So the juice manufacturing would be based on juice HACCP, and I don't try to be a juice HACCP expert, but it could be defined in the juice HACCP requirements. I would say a typical CIP in beverages, depending on the product, would be depending on production, if it's continuous production. If not, if they're shutting down every night, they would clean that night before they start up the next morning.
Okay. Mona again, how is well, I think we've just covered that one, haven't we? How is disinfectant more effective than sanitizer?
It's not necessarily more effective, it's similar.
Okay. And Amit, how effective is the CIP system in removing rigid biofilms from a surface? Are there any studies or research on this important issue?
I do not know of any specific studies, so it would just be based on the biofilms that form on the surface within the CIP system. So it would be based on your flow. So if the flow or the turbulent flow of is used and a high concentration is used and the chemical, based on that chemical used, you'll be able to get rid of the biofilms, though manually scrubbing surface might be better depending on what the system used is.
Okay, and Preet, could you please elaborate on gel method for cleaning?
So a gel is just kind of like the gel solution. So if you use any like gels, hair gels, or things like that, it's that kind of solution material that's made, and then that sits on the equipment and then for a certain amount of time based on the chemical, and then removed at a later date. So it's similar, like a foam is sprayed from the foaming unit. This is just kind of a gel that's placed on the equipment.
Okay, Fauzia, is there a best way to document CIP?
So there's various ways to document a CIP. You can have continuous documentation, or you can take manual recordings. So the continuous would be the chart. So it would chart your time versus temperature, as well as the flow rate and the chemical used. So generally you can get that all on one chart. If you're documenting it manually, they would want to take the how long it took, the temperature, how long it took and how long it was at that temperature, and then the concentration and how long the concentration stayed at the defined concentration, and then the flow rate as well.
Okay, thanks, Megan. Liz, any tips on the best way to clean internal electrical components of equipment?
Generally without water. So this was this was on wet cleaning. So the best way, internal electrical components, trying to more like of a dry clean instead of using chemicals or water.
Vacuum, maybe.
Right, or a vacuum, sure.
Yeah. Okay. Let's have a look at this one. Luendo at Temple. I think that must be me. When do we need to use ATP swabs, and when do we need to use hygiene swabs to monitor the environmental cleanliness? What information do we obtain from each type of swabs?
So ATP swabs, I believe, is a type of the Hygenia swabs used. So they have a type of ATP swab where they put it in the bioluminescent device to get the reading. And then you can do micro swabs as well on the surfaces for any residual bacteria that might be left behind. APC, kind of just like a generic bacterial count. So this would be done based on your frequency determination. So you could do it after every clean and do certain various random surfaces. Or if you're having like a problem area, you can continue to swab that after each clean. So the information that you would obtain from each type of swab would be kind of like the same thing, just the how the surface is clean and if the cleaning that you just performed worked.
Okay. Roberto, bacteria resist sanitizers. How often is it recommended to rotate sanitizers?
That I would imagine would be based on your chemical supplier. So they would be able to determine how often to rotate your sanitizers based on the products that they offer. And then based on any of your ATP or micro counts, if you're seeing an increase in those, it might be time to rotate out a sanitizer or try a new one. But I would work with your chemical supplier.
Yeah, I just want to flag up there, Mark Krause. If you do have additional questions after this webinar that are not answered, you can go to that link that's shown in the last slide of the presentation. It's there in the sidebar. I'll also include that in the follow-up email as well.
Sure, it's aibinternational.com/webinar help.
Okay. Thanks. Enrique, requirements to properly clean conveyor belts, COP, in a tub.
There's nothing specifically defined that would clean specific to conveyor belts. It's generally cleaned as a food contact surface if the food is transported on the conveyor belt. So you would generally clean it just as often as you're cleaning any other food contact surface.
Okay, Irina. Hello, please describe the type of chemical to be applied for different types of surfaces, e.g. stainless steel, hard plastic, etc.
I would also work on your chemical supplier for this. The different types of chemical would be based on what they offer and what they recommend based on your production environment. But yes, a chemical used on stainless steel might not also be applied on hard plastic surfaces.
Yeah. Ashish, yes. Can we use IPA as sanitizer in dairy? I don't know what IPA is.
I don't know what IPA is.
Okay.
Besides beer.
Yeah, that's true. Ashish, if you want to explain what IPA is, then maybe that will help us. Okay, David Castro, where to start when considering CIP cleaning?
So it would be based on your production environment. So if you have any tanks or anything that would be able to be hooked up to a CIP system, that would be where you start. And then based on the current chemical supplier that you have, they would be able to offer the CIP system or cleaning chemicals within the system. And then you would be able to implement the process from there. So if you're having a lot of downtime from personnel cleaning and disassembly, it might be a good time saver in order to get a CIP system implemented in order to have that consistent cleaning and to reduce your time, your downtime.
Okay. Okay, Morad, if there is no CIP system, what is the best criteria for washing area, especially in the bakery industries?
So if you don't have a CIP system or there's nothing that would need a CIP clean, you would follow either the COP, so any disassembly that you would take and then do the manual clean within, and then you would still follow the TAC, so time, action, concentration, and temperature. So you would still want a contact time of the solution, an action, so manually scrubbing any conveyor belts or parts or anything like that. The chemical, so the chemical will be used at a certain concentration, and then the temperature of the water as well. So generally a warmer temperature kind of gets rid of the visible soils easier, and then it's easier to then less action required and less wear and tear on the personnel.
Okay, and Roseanne, the listeria problem in bakery factory, how can we remove bacteria from non-food contact surfaces during sanitation?
So this, how can we remove bacteria? So it's the same way that you can remove it from a food contact surface is that you could clean with a chemical or kind of a disinfection step. If you're having it on like the walls, like I discussed during the presentation, like another facility was having listeria in their walls and using some high pressure spray, and then it was spraying on the equipment behind them. So that's why they had some recalls that they had to initiate. So it would be recommended to not use any high pressure sprays, and then in order to do some cleaning and disinfection of the surface, the non-food contact surface, in order to get rid of the bacteria, and then do a re-swab to make sure that you removed it.
Okay, lots of weird and wonderful questions today. What are the reasons, from Roshanara, what are the reasons sanitizer leaves spots on steel utensils?
It would be based on the sanitizer used, but also it could be based on your water. So if you have some harder water, that scale can be left behind with the rinse afterwards.
I thought that might have been challenging, but that's good. Yeah, very good. Jamil Azimi, there may be some traces of chemicals used in cleaning. How can we avoid traces of chemicals after cleaning?
So do you mean the traces of chemicals like after the wash step? So then that's when you would initiate the rinse. So you would do the wash, and then any chemical left behind, you could rinse it afterwards with any fresh water.
Okay. Jamil, there may be some traces of... No, I've done that one, sorry. Larissa, what would be the best cleaning agent for a caramel type product? I imagine sticky. It's going to be sticky, caramel.
Sticky, sure. So sticky. So first you would try and I guess scrape all the caramel off as you can, and then maybe kind of a foam or a gel solution to let it soak on there in order to release it a little bit better. If it's hardened, it might also take some like heat that you can remelt it and then have it be easier to scrape off.
Just a newbie question from me. I have no idea. Are you allowed to use solvents and things like that or not?
Yeah, you can use solvents.
Okay.
Just as long as they're used according to label requirements and all the necessary precautions are taken.
Okay. Chandra, what is the best chemical for CIP?
So it would be dependent on what CIP you're doing. So the caustic CIP or the acid CIP, and then any caustic solution based on your product or your chemical supplier would be able to tell you which one to use, because they all have different names based on who supplies them.
Okay, and Morad, what is the criteria for the design of washing area, especially in the bakery industry?
I don't think that there's any defined criteria based on the CFR or any regulations. You would want to have something that can be drained out of there. So definitely a drain in the bottom, just not somewhere that you would be able to are putting any or any equipment on top. So that can be avoid the drain, but also have any water that can be washed down the drain. Other than that, you could have your hookups there, so they're already pre-diluted and they're just using the hose that sprays the caustic or the sanitizer right there from the stations, but it would be just kind of based on the design of the facility.
Okay, and Vivette, can you explain the difference between validation and verification of cleaning?
Sure. So the verification would be like, did the cleaning work? So is your cleaning steps and you made sure that everyone, all the steps were followed, and then the surfaces are clean. So that's kind of like the verification is, did it work? And then the validation, is it effective? So you can continuously do this cleaning procedure over and over again, and it might clean the surfaces, but then did you validate it to remove any micros or any allergen residue? So if you can continuously clean, if you're producing a peanut substance and then an almond substance and you're cleaning and cleaning, but that cleaning that you're following isn't removing the allergen in between, then your cleaning isn't validated and it's not effective. So you need to kind of develop different procedures in order to remove that allergen protein.
Okay, Irene, how to establish the CIP parameters, or shall we rely on the validation or supplier recommendations?
It would be based on your system. So you want to validate your CIP system that you have at your facility. So it could be a little different than your neighbor. So you just want to make sure that you're validating your CIP. So the parameters, the concentration would be found on the label. So that range would be defined there. And then the time and the temperature of the solution and any action or flow rate that you need to use would just be based on your system. So you want to be able to use it and make sure that that's the effective clean. So your flow rate could be different than your neighbors or your sister plants. It would just be based on the system at your facility and what product you're producing.
Okay. There's no let up. Roxanara, what are the advantages of foam or gel over using liquid detergent and sanitizer?
So the foam or the gel would just be kind of like if you spray down an area and then you let it sit there and then you can walk away and rinse it. So it kind of does essentially sometimes the cleaning for you. So you leave it on and then you can kind of get something else done before you come back and rinse it off. So it's kind of just like a time thing. So you can use it and leave it on the surface and then go back later and rinse it off. So the liquid detergent or the sanitizer is kind of there where you're doing the cleaning and you're doing the manual brushing and removal of the soil.
Okay. Lecrage, do you know anything about honey? Please suggest best CIP system for honey industry.
I don't know much about honey, other than it's delicious, but I don't know what CIP system would work best for the honey industry.
Again, it's very sticky. I have it on my porridge every morning.
Yeah.
Maybe that can be a question that can be followed up later, Lecrage. Packaging lines, what is the best method of dry cleaning for packaging lines?
So packaging meaning packaging a finished product or making packaging? I'm
That's
not
a good
sure.
point. Yeah, maybe if you can clarify, well, unless you can give a general.
Yeah, so the dry cleaning for packaging lines, you can use any air to kind of blow it all down and blow it out of the equipment that you're using, whether it's case packer or something like that, any cardboard dust or plastic dust or any like things like that, blow it out and then sweep the floor. If you're same thing with producing packaging, if you're having any of that packaging or that plastic debris, kind of blow it out and then sweep it up, or kind of like a vacuum to get rid of any of the debris that in between, I guess, production.
Okay, and Andras, in case of manual cleaning methods, when manual chemical dilution is applied, how often should the chemical concentration be verified?
So it should be verified every time it's mixed. So when you're doing the manual cleaning, if you're filling a mop bucket or kind of a bucket with a brush or any kind of station, so you should test it during every use. So once it's mixed, you take however much chemical to however many gallons of water and then mix it up there and then test it. And then every time you're mixing a bucket, if that's what you have to do is make it every time instead of using a system, then you would want to test it every time you're making it.
Okay, and Ganesh, which chemical is good to remove protein scaling from? Is that THE? Is that something? I don't know.
I don't know.
After high protein slurry processing. Is THE an acronym for something? I'm not aware of it.
I'm not sure. Yeah, so anything to remove any proteins or fats or oils would be anything to remove use a caustic solution, and then have it go through all the steps of the time, action, concentration, and temperature there.
Okay, and Morad, what is the concentration of common concentration CIP materials like caustic and nitric acid?
So concentrations, like I said, are found on the label. So it could be anywhere from 2,000 to 4,000 parts per million, or 2.0 to 4.0 ounces per gallon. It's kind of all defined on the label itself. So all of them define it differently. It could also be measured in pH or conductivity in the CIP. So it would all just be dependent on the label. There's not one generic concentration for all caustic chemicals.
Okay, Victor. Recommendation for dry out equipment, time and temperature for spray dryers.
Again, that would be based on the label. So if the chemical, if you're using a spray dryer, you're producing with the spray dryer or using it for cleaning. So it would be dependent on the system itself. So you would leave it on or let it soak for a certain amount of time in the spray dryer, or kind of let it go through the system. Or the spray dryer is the one that's kind of doing the fogging or something. It would also be dependent on the chemical. So you would spray it out and let it sit on the surfaces before it either air dries or you can resume production.
Okay, just to clarify, IPA is something to do with alcohol, but not beer. Isopropyl alcohol.
Oh, isopropyl alcohol?
Yeah.
The sanitizer?
Yeah.
Okay, so yeah, the isopropyl alcohol is a type of sanitizer. So if I don't remember the question necessarily, but you would be able to kind of some alcohol sanitizers, you just leave on the surface and let it air dry. You don't have to do a rinse afterwards.
Yeah.
And most of those come like pre-diluted, so you don't have to make them yourself.
Yes, Sujit said isopropyl alcohol 70% can be used as a sanitizer after wet cleaning.
Yep.
Yeah. Rosin, how can we remove listeria contamination on non-food contact surface? I think we've done that one.
Yeah, I think that there was another question similar to that before.
Can you briefly, Ethan, can you briefly tell us about hazards associated with caustic used for cleaning?
It would just kind of be more of like personnel chemical exposure to the chemical to make sure that nothing is handled without the proper PPE worn and used in order to use it in your system. So the only hazards I know kind of associated with it would be personnel hazards, not necessarily product hazards, but definitely still talk to your chemical supplier, and they would be able to know any different hazards associated with the caustics, because some of them vary based on the chemical used.
Okay, Jennifer, what is the best way to ensure a tank dries after the sanitizer or rinse steps in a CIP system?
So I would imagine the best way would be to let it, a visual inspection. So make sure that there's no any water left behind or anything left behind. So the surface looks dry. So if it's stainless steel, it doesn't have that water coating on it, and then at the drain at the bottom, make sure that that's fully drained out and there's no residual water left behind. Okay,
Esther, what is the best method to clean 5,000 litre tanks isolated outside the plant, for example? Does it depend what's in it?
Yeah, it would depend on what's in it. So like flour silos and things like that, you don't necessarily want to use wet cleaning, because any moisture in it could then become like a mold harborage issue or any micro harborage within the system itself. If it's like milk or things, that generally follows the PMO, and you have to do a certain a cleaning every so many hours using like a wet cleaning, kind of like a CIP rinse, wash, rinse, sanitize before refilling.
Okay, and Thomas, do CIP systems come with a continuous monitoring system built in, or do you have to set up a monitoring system separately?
Some CIP systems do come with the monitoring built in, so they can you can set it up to have the monitoring system in. So it would have the temperature probes, the flow rate monitoring, conductivity probes, and then of course the time would be able to be monitored. So it does. A lot of them do come with it built in, and then you can have it on just a screen either in the lab or in an office or somewhere else, wherever you want it to be, wherever you want to be able it to be visible, or even on the production floor itself, so they can just kind of hit a few buttons and then the CIP system starts, and then they can print out a chart afterwards.
Okay, have you any idea the best chemical for cleaning an evaporator?
Do not. Based on where everyone is in the world, it would just kind of be dependent on the chemical supplied there, based on the chemical supplier.
Okay. Alvaro, what cleaning would you recommend for ceilings? We are considering foaming.
It would be dependent on what the ceiling is made out of. So if it's kind of just like a drop ceiling, we don't necessarily recommend foaming, because you don't want to get that wet and then have it just start to deteriorate and have any insulation breakdowns and things like that. If you have just like a nice stainless steel or any kind of like hard metal ceiling or something like that, then you can consider foaming, just to make sure that anything below the ceiling is kind of covered and nothing from the ceiling is then going to fall into your product stream or fall into your product. So you can cover it with kind of plastic or tarps or anything like that, and then do a clean of the equipment afterwards.
Liz Lee, bit of a long one. Have you had experience in cleaning refrigeration units, particularly where the fins are so close together that may trap particles and chemicals? Also, have you seen fluff after the cleaning and dried refrigeration units? Any experience of cleaning refrigeration units?
Mostly you would clean just kind of like the fans and the covers and then the back half of it as well, just to get rid of anything that got trapped in it, or just to make sure that the clean air is being circulated through. So generally they have a filter on the air, so hopefully nothing kind of gets trapped in there, any particles or anything, so then you'll be able to change out the filter every so often. And then the fans and the covers on them can be cleaned. You can take those down and clean those.
Okay, here's a challenge for you. It's a bit left field. Please, can you give a solution? A mouse died in the ventilation pipe and it could not be removed because of concrete roof. How do we remove the mouse? Any ideas? From a pipe in a concrete roof.
They gotta find some way to remove the mouse. I'm not sure how deep the ventilation pipe is, or if you can kind of somehow detach it or kind of get some kind of high pressure vacuum to suck it out or something like that. Some way to remove it, because otherwise it's going to smell really bad real soon.
We could send a ferret in there. Probably not a good idea. Ignore that one, please. I'm just the administrator. I've got a clue what I'm talking about. Okay, Vivek, what exactly would be the best cleaning time for removing flavour from the lines? Difficult without more information into it. What flavour, how strong?
Right, how potent it is, and what kind of system it is. So I'm not sure if cleaning time means the time in time, action, concentration, temperature, or just like the frequency of cleaning, how often cleaning time should be, every 24, 48, or 72 hours. It all just kind of depends on the system.
Okay, here's an interesting one. Well, I think it is. Abanji, is it possible to use a CIP in a chocolate processing factory? And is it possible to do a CIP without using water and detergents, but rather using butter at temperatures of about 80 degrees C? I
do not know. I would imagine a CIP is possible in a chocolate processing facility. It would just kind of be dependent on which kind of CIP you want to use. But I don't know. I've never heard of a CIP using butter at temperatures of above 80 degrees Celsius instead of water or detergent. Okay. Alison, can you see that one? Are you testing TPC when validating using micro? You can test for TPC when validating using micro, TPC, total plate count, or APC, aerobic plate count, any coliforms or yeast or mold, depending on the process. So you can use any of those kind of micro, either swabs or product testing itself. You can also test for pathogens as long as you're following the requirements around pathogen testing on product. Okay, Vivette, how effective is 70% versus 90% alcohol as a sanitizer? I'm not sure exactly the total effectiveness and how it's measured. Yeah, I guess it would be dependent on the surface that you're using it on. So I don't have a full-on answer for that. Okay, Violetta, for CIP systems, is it enough to check the pH of the water after final rinsing? Enough from a verification standpoint of the final rinsing. Yes, you can check as long as you kind of know your water pH and what you're using. So if you're using an acid, so you want an acid CIP versus a caustic CIP. So you want to be able to make sure that when you're testing it, you know what the pH results are going to tell you.
Okay, Lanelle, is it advisable to alternate caustic CIP and acid CIP to combat resistance?
So the caustic CIP is kind of the cleaning step. So you use it to clean, so to remove any like fats and oils and proteins and things like that from, so kind of to remove your product. And then you do the acid CIP kind of less frequently in order to get rid of the minerals. So any like the scaling or anything like that that we talked about previously, that's what you would use the acid CIP for. So it's not necessarily alternate. It's just you use the caustic to clean, and then you can add the acid CIP in order to do an additional clean of any mineral buildup.
Lekraj, what is the optimum temperature of water needed for a CIP system?
It also varies depending on product. You can do an ambient CIP, so it's just kind of at ambient temperature, maybe 70 degrees Fahrenheit, something like that. Or you can do a hot CIP, which goes up to like maybe 165 to 180 degrees Fahrenheit. It all just kind of depends on your system. So it's not necessarily an optimum temperature of water. It would just kind of be based on how your CIP works and what you're using it for.
Okay. Vicky Lewandowski, it's quite a long one. Can you clarify your answer regarding the use of air? If you use air to blow soil dirt from equipment prior to cleaning sanitation, do not use a compressed air. Using high pressure air can drive soils into niches, food for the bacteria. Using air can have the same effect as using high pressure water.
Sure. So I believe when I was talking about the air, it was for packaging, so not necessarily product. So right, I agree that you using high pressure air can then transport anything into niches and things like that, and then it could cause a micro issue later on. So yeah, if we are using air, it's kind of like a dry cleaning in a dry area, so it's not necessarily something that's going to do anything with product.
What is a critical control point for a CIP system?
So your critical control point would be kind of like your time, action, concentration, and temperature. So that's your critical monitoring, because all of those steps combined are what's going to make your cleaning work and be effective. So as long as you're hitting time, so if you define it for 15 minutes, you want to make sure that the minimum of 15 minutes is met. If you're having your temperature, you want to make sure that it's at a minimum of the 165 for 15 minutes at a certain concentration. So make sure that your chemical concentration is within the defined range, and then your flow rate as well. So to make sure that the turbulent flow is adequate as well. So those would be the 4 things to monitor.
Okay. Nasra, does the presence of Pseudomonas in processed water relate to a cleaning issue?
I mean, it would kind of just depend on what. I'm not very familiar with Pseudomonas as like a pathogen, so you just want to make sure that your water is from a potable source.
Okay. Ivan, have you got any experience with our recommendations for ozone disinfection? Have you any?
So within a cleaning process, no. I mean, I know that there's ozone injection into bottled water in order to then make it drinkable. So if you're using ozone disinfection of the water system and then you're using it for cleaning, that's kind of a way to make sure that your water is safe to use for a cleaning process. So some plants that are producing bottled water just kind of use the same water for cleaning.
Okay, Larissa, we're getting there. How effective is high temp, low pressure steam cleaning?
It would also, again, be based on the product. So high temperature, low pressure steam cleaning. So just kind of like a steam cleaning step within the wet cleaning process. So it just kind of be dependent on your product and your procedure.
Okay, let's have a look. Mark, what is a good substitute for iodine?
I'm not sure what in reference to what.
Okay. Any, like I say, any that we're not answering or we miss or skip, we will. You can ask at the AIB link that we will provide. Jeff Coombs, when is the best time to do a validation on CIP? Right after sanitation get done or at pre-op next day?
Generally, the validation of the CIP is done kind of right after sanitation. to make sure that the surfaces are clean and the cleaning work. So your pre-op step the next day would just be to make sure that the surfaces, it's more of a visual inspection to make sure that the surfaces are visually clean before you start production. But the validation of the CIP would be right after it's completed to make sure that it was effective.
Yeah, Lisa, it doesn't matter anyway because you add your name to the certificate yourself, so they're not personalized. You either print and sign your certificate or edit it in an image editing package. Right, I think Hein Timmerman just said iodine can be replaced by PAA. Yeah, I don't know what PAA is, but
Paracetic acid.
Okay.
I believe. Mm-hmm.
Ivan, ozone is used to disinfect water, food ingredients, fruit, vegetables, meats, and also food contact and non-food contact surfaces. Okay, I think we're over anyway. We're 5 minutes over. I think it's the last Food Safety Friday of 2019. You've actually won a prize, Megan, for the most questions answered. And that's your fault for finishing the presentation in 30 minutes.
Yeah.
So but no, it's great. Obviously, answering people's questions, fantastic. So thanks for the presentation. Thanks for your time and answering all the questions, Megan. So, yeah, we're going to leave it there.
Okay, great. Yeah, thank you. Thanks, everyone, for joining.
Yeah, have a nice weekend, Megan. Thanks very much. Appreciate it.
You too. Have a good weekend.
Okay, bye.
Bye.
Right, ladies and gents, we have run over a little bit, but I'm sure you'll agree it's worthwhile. We'll send the recording slides and I'll issue actually the certificate of attendance now in the sidebar. So if you click on that link, grab the certificate from Dropbox, you can either print and sign it or download it, open it in an image editing software, and then type your name. They're not personalized. You have to do it yourself. So thanks for your attendance today. Thanks for your attendance throughout the whole of 2019 on Food Safety Fridays. We will be back next year. We've got 30 webinars all lined up. And by the time you get back to work in January, in the new year, they'll all be on the website and you can start registering for those. So thank you again. Yeah, for those of you who do get time off and celebrate, Merry Christmas, Happy New Year, and we'll see you in a couple of weeks. Take care, everybody. Bye-bye.